All right. Our next video deals with rotations. Okay, these are by far the most difficult of the transformations to master because if you're not a very visual person, it's just tough to work out. So, what we're going to do is we're going to do these backwards. Okay, instead of doing it and counting it and talking about that way, I'm going to show you the coordinate notation first. We'll use the coordinate notation to figure out our new points and go from there. Again, unless you're just a really visual person, rotations are tough. So, ooh, look at that. Isn't that fun? All right, so let's go ahead and get our quadrilateral on here. So in this case, J, K, M, N. So J is at 1, 4, so over 1, up 4. So there's point J. K will be at 3, and then 1, 2, 3, 4, 5. Okay. So there's K, maybe. Yep. M is at 5. 1, 2, 3, 4, 5. Up 1, 2, 3, and 4. Cool. And then let's see. N is at 3, 1. All right, kind of this kite shape. Oh, forgot to label M. And then here's N. Cool. All right. Yeah, we can do a better job of that. Here we go. Now, as I mentioned in the intro video, okay, when we rotate, we need a few things. One of the things we need is an object to rotate, so here's our quadrilateral. We also need to know what we're rotating around. In other words, what's the one point that stays fixed? Because if you've ever been on anything that rotates, for example, a merry-go-round, there is one point on the entire ride that never moves. That's that very center post. Okay? Same here. We need to know what's that one spot that's never going to move. We always assume that it's the origin, okay, unless we're told otherwise. So our one point that's going to remain stock still is this point right here. Everything else will rotate around. Okay? Remember, we also assume that we'll be going counterclockwise. Okay? We'll always assume that, counterclockwise rotation. Now, I said we're going to start with the coordinate notation first and then kind of work our way back. All right? Here's the notation for this. So we're going to start out with our points X and Y. So for example, I'm going to use N here as kind of our XY guinea pig. Okay? If I rotate this 90 degrees, okay, it's going to end up right here. Okay? Now you may be thinking, Mr. Lamar, how do you know this? How in the world do you know that N prime is going to end up here when it started here? Well, number one, I've done this a few times. But number two, I'm a visual person. I can see that right angle as it's being formed. And I'll show it to you here in just a minute. But let's look at N prime's location and see if we can work out this coordinate notation. N prime is located at the point -1, 3. So, -1, 3. Well, let's look at that. How are these 2 points related? All right. Well, notice the 1 and the 3 have kind of swapped places here. So let's write that in. Instead of xy, they're going to trade places. I'm going to write my x coordinate last, my y coordinate first. Okay? Let's look if there's any other changes. Okay? X started as 3, and there's that 3, so that really didn't change other than its spot was first, now it's second. So 1 started second, it needs to be first, but notice it's the opposite. Okay? +1, -1. So here's my rule, okay, my coordinate notation. If I'm going to do a 90-degree counterclockwise rotation around the origin, here's my original starting point, my pre-image. Here's what my image is going to look like. The x and y trade places, and that original y coordinate becomes the opposite. Okay? So let's talk about how I knew that N was going to be here besides already knowing this notation. Well, here's what I'm going to do. I'm going to draw from the origin an L. Okay? There it is. Okay? I had to go 3 units over, 1 unit up. Okay? I'm going to make a 90-degree angle with this first line. So 90 degrees would put me here. So again, I'd have to go 3 units up. Okay? Notice there's that nice right angle. And if this was facing up, if I rotated it around, now this L would face over. Okay? This is one way of counting. I went 3 over, 1 up, so I need to go 3 up and 1 over in that counterclockwise rotation. problem with using these L's is if I keep drawing them, okay, my whole page becomes nothing but these L diagrams. Okay? And that's why I don't like teaching it that way. Instead, I like teaching the coordinate notation, and we simply use it. So, if that's where n prime ends up, okay, let's talk about j. All right. Well, I'm going to take j's coordinates, flip-flop them, so let's do that. So 4, 1. But notice, I need to make that y coordinate its opposite. So j prime is going to be at -4, so 1, 2, 3, 4, and then up 1. So there's j prime. Right? Let's try k. K was at 3, 5, so I'm going to rewrite that. 5, 3. And remember, the y has to be opposite, so in this case, -5. So let's draw it. 1, 2, 3, 4, 5, and then up 3. 1, 2, 3. There we go. There's k prime. Wonderful. M was at 5, 4. So let's write that out at 4, 5. Cool. But remember, y is the opposite. So that's a -4. Let's write in. 1, 2, 3, 4 to the left, and 1, 2, 3, 4, 5 up. There's M prime. Let's go in, draw our lines, make a few more observations. Well, what do you know? This is another rigid transformation. This and this, they're exactly the same. Okay? If we use our coordinate notation, okay, we can make these rotations, which are insanely hard for most people, really easy. All you got to do is switch your x and y coordinates around, and then make the y its opposite. Easy. If you're not given coordinates, some problems don't. They won't give you this. Okay? They'll simply give you the drawing and say, hey, rotate it 90 degrees counterclockwise. Well, make yourself a quick list of all of these wonderful points, just like we had here. You write them out. J's at what point, M's at what point, N's at what point, whatever. Once you do that, write them out again, flip-flopped, and make that first coordinate the opposite of what it was. Draw it in, and you're done. Okay? Not difficult at that point, just time-consuming. Okay? Let's talk about another rotation. Okay? This is the 180 degrees counterclockwise rotation. Now, technically, you might make yourself a note. If you're going 180 degrees, it doesn't matter if you turn to the left or the right, okay, clockwise or counterclockwise, you still end up in the same place. But again, we always assume a counterclockwise rotation. We always assume it's around the origin. Okay? So I'm just keeping that wording the same. So let's draw on our quadrilateral. Notice, okay, we're going to keep these points the same just for ease of use. So at 1, 4 is where J will be. Okay? K will still be at 3, 5. M will still be at, let's see, 1, 2, 3, 4, 5, 4. So there it is. M we said. And then N still going to be at 3, 1. Okay? So that doesn't change. And I think I've done those all in the wrong color. And you think, wow, Mr. Lamar, you're being really ridiculous about that. Yeah, sorry. All right, so let's color those lines in for us. Cool. So let's talk about the notation. Okay, if I'm going to go 180 degrees, okay, what was here, okay, and we're going to rotate it, is going to come all the way around, and it's going to end up over here. Okay, because if 90 degrees, okay, then 180 degrees is going to shift everything over down here. So let's talk about N. Okay, we used it before. It's kind of our point of reference to figure out this new coordinate. Let's do it. If N is here, and I go 180 degrees, so all the way around, 180 degrees, half a circle, we're going to end up right here. Okay, this will be N prime. Okay, so let's look at that new coordinate. That's at the point -3, -1. So I'm going to write that in for N prime. -3, -1. Okay? Well, let's look at it in its original. Well, notice the 3's in the same spot, the 1's in the same spot, so okay. So x's and y's really didn't trade places. But what did happen? Positive 3, negative 3. Positive 1, negative 1. It's opposites. So in other words, I can simply take all of these points, find their opposites, and that'll give me a 180-degree counterclockwise rotation about the origin. Now once again, Mr. Lamar, how in the world did you know that this point goes here? Well again, if I use that L method, 3 spots over, 1 spot up, okay, I'm going to rotate this 180 degrees, okay, so that would come out 3 spots, counterclockwise, down 1, that's a 180-degree rotation. And again, if you sit here and draw all these crazy L's, your page fills up in a hurry and it gets very complicated to read. So that's why I don't teach you to draw them that way. It just gets unnecessarily complicated. Using the, oh goodness, using the coordinate notation is a much easier job. So let's do it for J. So J was at 1, 4, but we need its opposites. So negative 1, negative 4. So let's draw it in. So negative 1, down 1, 2, 3, and 4. There's J prime. All right? Let's try it for K. K was at 3, 5, so K prime is going to be, again, at 3, 5. But I want the opposites. So negative 3, negative 5. So negative 3 down 1, 2, 3, 4, and 5. So there's K prime. Easy. All right? How about M? M was at 5, 4. We'll again use the opposites. Remember our coordinate notation there. So negative 5, negative 4. So negative 5, and then let's see, 1, 2, 3, and 4 puts me right there. M prime. Let's draw the lines in. Do them in the right color. And there we are. So let's make some observations. Once again, it's a rigid transformation. Notice they're exactly the same. The only major difference here, okay, is that, well, this is 180 degrees as opposed to what we did before, which was just 90 degrees counterclockwise. All right? Now, let's make ourselves a separate box for a moment. Okay? This is where we're going to have to kind of get serious here. This is 90 degrees counterclockwise. This is 180 degrees counterclockwise. It also works, by the way, if you go 180 degrees clockwise. So that rule actually does double duty here. It works for both. But the question becomes, well, what if I don't go counterclockwise? What if instead I go clockwise? Well, what's my coordination going to be then? Okay? Well, here it is. Write it down. 90 degrees clockwise. Okay? You start off with your original x's and y's. Okay, that doesn't change. You transform it, in this case a rotation. Now let's look at our counterclockwise example. We said we're going to switch our x's and y's. That stays true. But notice what changed. Y's were opposite, okay? Because counterclockwise is a left-hand turn. This left-hand coordinate is what was changed. If I go clockwise, that's a right-hand turn, which means this right-hand coordinate is now the one that has to change. This is the rule, okay, your coordinate notation for 90 degrees clockwise rotation. You start with your original points. To do the transformation, flip-flop them, and make your x-coordinate its opposite. And that'll give you a 90 degrees clockwise rotation. All right? So there you go. All the different ways that we're going to rotate this year. Last but certainly not least, we'll talk about dilations in the next video, probably the easiest of all of the transformations to do.